All right. Hello, everybody. We are in section 3.3, and we're going to continue our study of functions and their inverses and how we can do calculus with that. And so in this section, we're going to focus on exponential and logarithmic functions, which I know tend to have a bit of a bad rap with students, but I just encourage you to try to put that out in your mind, have an open mind towards these functions, and hopefully by the end of it, they won't seem so scary and miserable as they might have in the past. So for now, I'm going to think about f of x as log base a of x, and then its inverse, of course, is a to the x. Because these functions are inverse to each other, we know certain things. For example, we know, here, I'm going to use black for my color here. We know that a raised to the log base a of x is just x. And we know that the log base a of a to the x is also just x. Of course, this one, x has to be bigger than 0, and this one is for all, the second one here is for all x. The key relationship for understanding logarithms is to understand that log base a of x is y if and only if a to the y is x. And you can see it here. This x, right, is equal to a to the y. So if you put a y right there on the exponent on a, then that's what x is. So the logarithm of x, this whole thing, which we're calling y, is the power that you put on a to get out x. And so in some ways, it's right here. A to the log base a of x is x. This is the power that you put on a to get out x. Okay, so that's review. We did that last time. I just felt the need to review it again. And so what we're interested this time is, what is the derivative of the logarithm? And this is a really interesting question. I could just give you the formula. And to be perfectly frank, if you just want to skip to the formula, it's not going to kill you to just do that. But for those of you that love learning, here we go. Let's see if we can figure this out. What is the derivative of the logarithm? And so I'm going to go back to the derivative f prime of x. I know by definition is the limit as h goes to 0 of f of x plus h minus f of x all over h. I'm going to erase that and just say, well, my f is log base a. So I'm going to plug in my logarithm. So I get log base a of x plus h minus log base a of x all over h. So far, so good. And now we look at this and we think about all the different tricks that we've done in the past to try to simplify this, and none of them seem to apply here. However, hopefully you're thinking about the rules of logarithms, and you notice there's a negative between these two logs. And so I'm just going to try the next thing. I'm going to do the next thing. Whoops, I'm going to say that this is the limit as h goes to 0 of, well, I can write this as log base a of x plus h all over x all over h. And now I'm going to do basically nothing new. I'm going to go down here. Let's draw an arrow. I'm going to basically do nothing new, but I'm going to think about this h as being a 1 over h right there, just to help me be able to see this problem from a little different perspective. It makes the notation easier. So we have 1 over h log base a of x plus h over x. Now, I'm going to do something that I admit is going to be difficult to know why I did this without seeing the end of the story. But just go with me for a minute. I'm gonna put an x upstairs. I'm going to do it in red here. I'm just going to put an x up here. And then to do that, I've got to put a 1 over x downstairs to fix that. Do we agree? So that's what I'm going to do in the next part, but I'm going to write it as a new line because, well, I want to write this neat and nice and tidy. So I'm going to write this as the limit as h goes to 0 of 1 over x times x over h times log base a of x plus h all over x. And now I realize this limit is involving h. H is what's in motion. X, even though x is a variable, in this limit, x is static. And so I can pull this constant out of the limit, and I can view this as 1 over x times the limit as h goes to 0 of x over h times log base a of x plus h over x. And notice I'm being careful to write everything in an orderly way, step by step. I'm not taking any shortcuts. I'm writing limit every time. I'm just being methodical, careful. This is how you want to do your own limits. It really helps keep things straight and clean. Okay, the next thing that I want to do is I want to realize that I can pull this thing inside the logarithm as an exponent. We usually think of it as log base a of x to the r. We can pull the r outside and write it as r log base a of x. I want to go the other way. I want to pull the r in and go backwards. And so I'm going to write the next line like this. I'm going to say, well, this is 1 over x times the limit as h goes to 0 of, gets a little crazy here, log base a, let's put a parenthesis here, x plus h all over x. You know what? Hold on. Let's do two things. I'm going to pull this in, but I'm also going to write the inside a little different. Instead of x plus h, I'm going to write this as 1 over h over x. Make sure you're comfortable with that. I'm not canceling incorrectly. This is 1, and this is h over x. And then I'm pulling this part in as the power, so it's got to get in here and show up as x over h like that. So that's where we are. Now I want to unveil the motivation. We talked about this limit last time, and this is one that you should recognize because we went over it. We said that this is just e. And I give you no explanation for it. I just said that's what it is, and that's what I'm going to do now. There's a different way to approach this whole topic where I can prove everything from first properties, but the way that our book does it, you sort of have to start with this limit. So we'll start there. So I'm thinking about this limit, and I'm looking at the inside of the logarithm, just the inside. Just ignore the log. Do what you wish you could do and act like that part isn't even there. Just look at this part of it. And it feels like, man, this is almost the same as down here. I've got something here, and it's going to 0. As h goes to 0, h over x goes to 0. I need 1 over that something upstairs, and I don't have that. I have x over h upstairs. And sort of the stroke of genius here is to realize that we can write this as limit h goes to 0 log base a of 1 plus h over x to the 1 over h over x. And that's a lot of algebra maneuvering. We've done a lot of canceling and moving things around, but please realize at this step, from here to here, it's one step. Each line was just one step, so each individual step isn't bad. 1 over h over x is just x over h. But by writing it in this form, I recognize, oh my goodness, I have this, these are the same limit. As h goes to 0, this guy is going to 0, and I have 1 over something going to 0. And so I know that this limit exists. This is going to be 1 over x, because with regards to h, x is just a constant. 1 over x times log base a of the number e. And so that's what we figured out. And so the question that I want to ask is, can we simplify this? Is there a way that we can simplify this? Maybe we'll actually say one more line. We'll say, okay, so far we have d dx of log base a of x is 1 over x log base a of e. And so there it is. But can we simplify this? Somehow log base a of e is not really very satisfying. And so I want to recall the change of base formula for logarithms. So if you have log base a of x and you want to be in a different base, say base b, it's just log base b of x, exactly what you want, but then you divide by log of the new base, so log new base of the old base. So log base a of x, you can switch to log base b of x and then divide by log base b of the old base a. So I'm going to do that. We typically want to work in log base e, which we write as ln, natural log. And so I'm going to go ahead and I'm going to think about this expression. Let's say it like this. We'll say, so log base a of e. I want to write this as natural log. Well, first off, we'll just say log base e of e over log base e of a. Nobody actually writes it like that. We would just say, well, this is natural log of e over natural log of a. But you should recognize right here, log base a of a is always 1. So this is 1. And so I get 1 over ln of a. And so it does clean up quite a bit. And so here's the formula that people typically write down and memorize. The derivative of log base a of x, I'll just write x instead of parentheses x, log base a of x is 1 over x times the natural log of a. And so we did it. We figured that formula out, and in the next videos, I will just work through examples and implications of that formula.